what I got today as a presentation, today we're basically gonna set up, start to end, a multi-actor invariant test. If you've been at our office hours, you know that the Recon starter pack has a file called target functions. And what we're gonna do is we're going to edit the target functions. First of all, we're gonna edit it in the traditional way by adding what are called proxies. We basically deploy a proxy, we'll have a modifier to change what the proxy is, and then we'll have these functions called the proxy. And what you'll see is that it's a very low level setup. And I personally really dislike it. I feel like it creates a barrier for beginners. It basically doesn't help beginners, and it also makes logs just harder to debug. And so the second part of the presentation will have me kind of struggle and actually reverse engineer. So you'll see me literally struggle to try and make the target functions into a reusable contract. And we basically will have more than one target functions as a means to allow us to have this multi-actor setup without proxies. So without further ado, I'm gonna share my screen. Let me know when you see it. Amazing. So we have Recon. I'm gonna very quickly show the improvements of this week. We basically changed the sidebar so that it's sticky, so that if you have as many jobs as me, you're actually able to check the menu at all times. And an upcoming feature that we have is going to be campaigns. We're working on it. We're almost there. We have recipes and campaigns working. So we should be pushing them to staging next week, or maybe next office hours we'll demo them. For today, we're gonna use the Create Chimera app. So if you wanna follow along, you can go at Recon fuzz Create Chimera app, and you can use template. So you basically just create a new repository and follow along. I'm gonna do it the good old way by doing a git clone on a new repo, and I'll call it target recon demo. And we're basically gonna clone the repo. GitHub is struggling for me. Unfortunate timing, but it is what it is. Let's give it a minute. In the meantime, I'm gonna see if I have a backup download of Create Chimera App. There we go. So I'm just gonna do it off of a backup, and if GitHub keeps struggling, we'll just live with it. So let's see what we got here. We got our counter. We got our target counter, and we have our Recon setup. Again, this is something you have access to if you go to Recon Fuzz, Create Chimera App, open source for everybody to use. And if we look at our target functions look a little something like this, where we have a function that is public, and then we have a target that we call, and the functions that we call, and then we have this alternative version of a try catch, and then we have a stateful before and after. I'm gonna remove this one. I'm gonna keep the increment, and I'm gonna keep the set number. So this is as simple as it gets in terms of your target functions. There should be very little to learn at this point. We're just doing the equivalent of grabbing the boilerplate off of the Recon UI, and basically we just get these target setup. So we have set number and increment, and we basically match them. Then perhaps we may want to have a property for the number. So we'll call something like check number above target, and basically we'll assert via T that number, so counter.number is less than a variable that we'll declare here of uint256 recon canary, which we'll set to, let's say, 118, and then we'll just do something like so, canary triggered. And so we expect Medusa to be able to break this very rapidly. What Medusa should do is it should set the number to a number above 118, and it should be able to break the code. Let's see if we have any weirdness in compilation. Let's just run Medusa. Seems like we have a build issue, so let me just try and forge build. I'm gonna set SOC version to 0.8.22 just for the sake of compilation. Honestly, never seen this error, broken pipe. Forgot to save. And so the only change I made is we're going to use SOC 0.8.22 just for the sake of using a version that I have on my machine. I doubt there's going to be questions so far. We're just setting up our target functions and we're just going to run them. We expect this to break in a few seconds. So let's see what happens. There you go. Medusa broke it. And just for the sake of a full demo, when Medusa breaks something, we will typically go on get recon /tools/Medusa. We can grab our log and we can basically generate our test file by setting the number to a number above 118. Obviously, Medusa breaks the property, and that's it. So at this point, let's say we wanted to test this simple setup by having multiple actors. So instead of wanting to break a single canary, let's say we want to break the canary for multiple actors. So the first thing we will do is we will go in the properties, and we will have to write some sort of let's say a property which we'll call check the canary multi-actor. And the reason why I'm using assertions is that if we were to use Echidna, if we use assertions everywhere, then we can get all of those tests with one run. Whereas if we use property mode, we will need two. That said, we could also just use critic underscore for a property in Medusa, and we will basically just have a return spool in that case. So they're basically equivalent. That said, we will return true by default, and then we will want to return, we will want to basically check, given all actors, ensure that all of them do not break the property. And so this is kind of our current goal. So the next step will be to set up the actor-based setup. So I'm gonna write it up here, but typically you will set it up as a separate contract. But basically we would have a contract called proxy, and the proxy would have a single function called, we can call it call, we can call proxy, we would most likely call it proxy, and then we would have an address target and a bytes memory call data, which obviously we can't call it call data, so we'll just call it data. And this will be an external function. And basically through this function, we would effectively do something like target.call with the data. And so this will be the simplest possible way to set up a proxy. If we wanted to also return the success and the data, we will do something like this. And we will basically just assign it here as success and data. And obviously data is called twice, so we will call it something like return data. And so this will be the base setup. And the reason why I really despise it is that because of this setup, we now would have to write something that looks a little like this. We would have to call something like proxy dot proxy. So maybe we'll call it I don't like the double proxy. Maybe we'll call it call. So let's just call it proxy.call. And then we will do something like counter. And then we would encode the increment call. So we could do something like counter.increment.selector. Or actually we will do counter.increment. So most likely we'll do ABI.encode call of counter.increment with no parameters. So for the sake of getting to compilation, we'll just do one function for now. But this is roughly what our translation will look like. We obviously don't know what proxy is. For the sake of demo, for the next 10 seconds, I'm just going to deploy a new proxy just so that we can see what happens. And then obviously we'll set it up properly. So let's just do proxy equals to new proxy. And let's see if we get compilation. We have an error with this because we want to cast it to an address. And then we will try and fuzz. So if our function works, then we should expect the increment function to be called. And so for the sake of debugging, obviously we could go in Foundry actually. Let's just do that since we have our Recon setup. We may as well do that. So we're gonna go in the critic to Foundry debugger. We're gonna call counter increment, and then we're gonna grab the counter, most likely via counter dot counter dot number. So let's just do a console.log here. This will be the only time I don't add a text descriptor to the line, and then we can just forge test VV since it's the only test we have. So we know it's the one test that is gonna get run. Let's see if we achieve it. Actually, we have more tests, so maybe we'll get something else. But as you can see, we got a counter increment from 1 to 2. So I'm gonna check the chat if there's any questions so far. But fundamentally, all we did is we set up this proxy contract in a way that allows us to perform the call on behalf of that. So if you have a question, drop them in the chat or let me know. Feel free to unmute. That said, the next step should be fairly straightforward. Let's move the proxy definition to the setup contract. Let's then declare proxy, for example, 1, or actually we probably will do given a message.sender, we would assign it to a proxy. So given message.sender assign to proxies. So this is where we will go to our medusa.json file, and you can see that the sender addresses look like this. A known, how do I put it? Like a known interesting aspect of this is that this is not 1,000, or actually I always get confused about this, but basically you have to cast this into address in a specific way, otherwise you're gonna get the wrong address. So we'll see what happens, but let's go in the setup function. Let's most likely set up a proxy, which is basically going to be a list of these, or rather, let's do a mapping. So mapping address proxies. And so every time we have a different message.sender, we're going to set the active proxy, and we'll have a default proxy just to prevent a scenario where if I mess up the address, I end up not having any of them. So let me just add a active proxy equals to, or I guess we'll sort out the default case in a moment, but let's just start deploying a few of these. So we'll do active proxy is equal to new proxy, and then we'll set proxies square bracket address of this value to a new proxy. And this is where I think I'm gonna make a mistake, because this value will actually not be equivalent to this, whereas if I think if I cast it to bytes, it's gonna work. And I think the way we can test that will be to never use the default value. So we're gonna have potentially some confusion for a moment, but fundamentally all I'm doing is I'm trying to assign the default senders from Medusa to the proxies so that they are matched. And so let's do that by adding a modifier. Let's call it modifier with proxy, and the modifier will call the function at the end, and before that it's going to set the active proxy, which I guess I'll just rename to proxy because that's the convention we were using. I'll set it to proxies square bracket message.sender. And I guess the simplest way to test this, I mean, for compilation will just be to run it, but to test it if it works will be to assert that the currently active proxy is not the address 0. So first of all, we get a revert. We'll have to check why, but let's do a t proxy different from address 0. Proxy is unset. And the, well, in this case, because we're using Foundry, we should actually have error here, simply because our default sender is going to be different between Medusa and Foundry. And so if we wanted to fix that, we would actually have to grab our at least our deployer address and change it. But fundamentally, we showed that the proxy is unset, which means that we are making a mistake, at least at this level. Let's go in the Medusa fuzz and see if we get the same issue, which should be due to the fact that this is not the value 10,000. This is actually bytes 32 of 10,000, which is a very different value. So let's see what we get. And it seems like it's actually working. So maybe it was my imagination. Let's add back our test, which we can actually use. Well, we definitely want to use something smaller like 3, let's say, to verify that we get to that value. So we would basically call increment 2 times to go from 1 to 3. Let's see if that's the case. Should take a second. There we go. So we can again grab our debugger, drop it in the tool, and you can see that we increment twice and that we check to achieve the level of coverage I mentioned. So once we get to this point, we would continue by simply applying this rule everywhere. So we will do a with proxy on every target function, and then perhaps we will move this property here so that it will be checked as a property. So I'm grabbing the Recon canary, I'm gonna drop it in the properties file just for good management, and then I will just finish by encoding this call, which will look a little like proxy call address counter set number. So we basically ABI.encode call of counter.set number with a parameter of new number. And by the way, encode call gives you type safety, so it's a decent check. And then this will be counter. And at this point, we wouldn't care about the result, so we will most likely stop at this point. We will then change the canary to 1E18 as a means to verify that we can achieve that coverage via these target functions, where we would proxy to set number, set it to a high value, and then break the property, or perhaps double in incrementing and then setting the number to break the property eventually. Let's see if that's the case. There we go, the canary was triggered. You can see how the shrinking by Medusa makes it so that it breaks it on the first instance by finding a random number above 118 and then verifying that we're there. So this is fine. There is nothing wrong with this, beside, at least from my perspective, the fact that we had to go from a high level encoding to a low level, or at least I would consider this a low level. We have to use the call function. We will have to check explicitly for the return value. We would, I think there is no low level contract existence check either. And then lastly, the encode call is really not particularly nice. So at this point, I want to poll the audience. Do you guys think this is fine? Like, if Recon allowed you to do this, would you be happy with this? Or would you prefer if there was a better way, like an easier to read way to look at your target functions? What do you guys think? Is there a better way to write target functions, or is this fine? Should we settle for this? I'm gonna make the assertion that there is a better way, but that it will require more setup. So I guess we'll explore together, and we'll you get to decide whether this is fine or whether we should actually change our ways. So I'm going to add everything and check out into a temporary proxies branch, and then I guess I'll just check out again into targets, and I'm going to undo the vast majority of the changes. We'll go back to our direct targets. Something like this. I'll remove this. I'll check the Recon canary. Maybe it's already declared in the properties. We'll remove from the properties, and we will get rid of proxies. And instead of proxies, we will be instead deploying target functions. So let's see if we can okay. So let's see if we can make this work. I honestly have no idea, but I feel like the ideal scenario will be to write the target functions as these functions, the simple functions, and then to have a abstraction in the setup contract to make it so that the target functions can be proxied into via another abstraction. And so I think what we'll do is we'll call a new contract called the target functions dispatcher, and we'll basically give it a go. We'll most likely set the target function dispatcher to actually be all of this stuff. So we're not getting rid of the target functions. We're simply changing it to have an additional layer of abstraction. Let's see how that goes. I'm gonna remove this check, we don't need it. I'll remove this as well. And so our base target functions will look like this, but it will no longer have any of these aspects beside the EVM if we need it. And then our target functions dispatcher instead will need to have some sort of a modifier to change the target will call, and then we'll basically call it. So we go back to our setup. We'll have effectively the same setup as proxies here, which will, I guess we'll just rewrite. So mapping of address to the target functions proxies will then, this is not found because we need to import it as target functions. So dot slash target functions, and then we can delete this. We'll then go to the target functions dispatcher, which will actually be our base target function. It will have our properties, etc. So we'll call this the dispatcher, and we'll have to change the critic to foundry to use the dispatcher, and the critic tester to also use the dispatcher. We'll then go to the dispatcher. We'll add a uint256, or actually we can just use a modifier, but an alternative to this will be to have some sort of an index here in each parameter, so that we would receive the parameters as built by Medusa and we will forward them, but we will then have an index to switch. But we can also use a modifier here, modifier change target, and then the modifier will effectively perform the operation, and given our proxies, it will basically do proxies square bracket message.sender, and it will set the active proxy. So this will be target functions active proxy, so I'll just call it proxy, and it will set it this way as proxy blah blah blah, and then proxy dot counter increment, that's what we will call, and then we will call the same thing down here as proxy dot counter set number with the new number parameter, and we will need to use the modifier up here to ensure that that works. Now I don't know if this will compile, so let's see what we get through Foundry. Forgot a semicolon. Abstract target is we no longer are anything. And then I guess we miss the counter because we're no longer anything. We most likely need to be properties. So this could cause issues with the linearization of the contract. So let's see what happens when I have properties twice. Definition of a base has to precede definition of a derived contract. And that's most likely because we created some sort of a loop here where this is going to be properties. Properties is going to be set up. So let me see. Maybe we'll make this setup instead. No, we're gonna have the same issue. So let's see if I can avoid this by just deleting the contract, going into setup, declaring it here as contract target functions, and then deleting it that way. So now we may not have access to counter because we don't inherit from this. So this definitely needs to be set up. But now we have a linearization issue. So let's see what happens with target function dispatcher, which is properties. So let's see. Proxy.counter increment. Where properties is setup. So maybe if we remove properties for now, since we're not using it, we should be okay. But I'm pretty sure I'm missing something. So let's just see what happens. Target functions is set up because this is before after, which is setup. So we go back to that. So let's see if I can get help from the audience. Do we have any advice here on how to unscrew the inheritance tree? Otherwise, you'll just see me suffer for a few minutes. I'm not afraid of it. Just if we can avoid it, I'd rather do that. But let's, I guess, let's just see what we could do. Well, first of all, we could actually get rid of this.
Follow you the last minutes, so.
Okay, you lost a piece, but basically what I did is I have a target function dispatcher. The dispatcher will get the current target functions and it will call it. Whereas the target functions, I've changed it to be the set of functions that we will call to the target contract. So the target functions will call counter, and then we actually have a dispatcher that will call the target functions. By doing that, we're creating another contract, so we have more complexity, but we're never using low-level code. Instead, we will have a similar logic for target switching, but now the setup will look like this, where we simply have the current proxy, and then we have a function that calls that proxy directly. Does that make sense?
Yeah.
Yeah, so the question is, the first question is whether this is simpler. Do you think this is a simpler setup, or do you think this is actually more complicated now that you see how it's working? So would you rather go to the low level, or would you try and do this?
High level might pay off more if it's getting even more complex and bigger code base, I think.
Yeah, let's look at a real project. So let's look at eBTC, something we've worked with, we did workshops with. We have spoken about eBTC. We have multiple recordings if you want to go check them. But you can see in the target functions for eBTC, this is the wrong 0.8. Just a second. So if we go here, you'll see that this is what happens when you have a really complex code base like eBTC, where you have bytes for hints, you have numbers, And so you'll see here we have abi.encode with selector, the amount, the bytes, etc. And so now you're doing all of these calls at a low level way. And so the like this is literally the proxy call here, you can see it, but and then this is all clamping. So by having this additional layer, you can abstract that away. So I'm gonna try and spend a little more time on this to see if I can fix it. I would say that the main difference is going to be that this target function basically becomes a contract itself that is then called, and so the target functions becomes the actor. That's really the main difference. So I think if I try and compile now, I should have an easier time. I'm just gonna have issues with figuring out what the counter is, and that can be solved fairly easily by having a constructor. I guess I'll just pass it as counter, and I'll set my variable counter. I'll just do counter lowercase, even though it's an immutable. And then I'll set it here. And then I'll change the constructor here to pass the value for each of them. And then our new target functions, which is called target function dispatcher, will basically set the proxy and it will then call it. So let's see where we're at. We have properties as missing due to a comment. Let's see if this works. And the problem we'll have, first of all, we have a revert, so we'll have to investigate it. But one of the problems we'll have at this level, especially due to Medusa and Echidna versus Foundry, is that this message.sender, especially if you use more than one, can cause issues. So if you're using only one, you can go in the Foundry book and search for the default sender, I think. So if you search for a few moments, you eventually will find that this is the default sender. And so if we only use one of them, we could solve it this way by setting it that way, which will make it so that our Foundry debugging and our Medusa runs would have the same addresses for every target, which actually you will do it by doing it here. But that will be one way. Whereas what I think is really good, especially for early projects and for beginners, would actually be to have the modifier being turned into a function. So you will call it function change target, and you will basically just change it to whatever. So maybe we'll use a uint256 internal counter, and then we will basically just do modulo free, and then we will set this up from a mapping of addresses to a mapping of uint256, and so this will be on 0, this will be on 1, and so since I'm doing this, this is basically an array, it's no longer a mapping, so I may as well just change it to be a target function square bracket array of proxies. And that way I can just go here, I can proxies dot push, and basically we have a more reusable system where we're pushing the targets, we go to our function dispatcher, we're gonna get, we're gonna get the internal counter, maybe we plus it or plus post increment, and then we're just gonna do a modulo proxies.length. And now we basically have the change target set up in a way that anybody can understand. And most importantly, if Medusa can minimize its trace without needing to change the target, you will always get the minimized trace with something like this, where it's always going to be one command and been done. Whereas if it needs more than one target, it would actually show you that. And so that's a bit of pseudo assertion. It's not fully founded. We need to test it more. But this could basically help you see setups that could be set up with a single address versus setups that require more than one. So at this point, I'm trying to just get the compilation going. So let's see where we're at. We're at, let's go to the critic to foundry setup. We have counter increment, and now counter increment will look like this, but because of the fact that we never set the first one, then it will never work. And so this is interesting how Medusa should actually be able to figure that out, that nothing will ever happen. And so it should change target once to set it, and then it should be able to reach the coverage that we're looking for. So let's see if that's the case. In the meantime, I'm gonna check in the chat. Do you guys still hear me? Amazing.
Yeah. Yes, can still.
So at this point, we got the fuzzer running. Obviously, we are terrified, right? Terrified that the property wasn't broken instantly, but it may also be that I forgot to set the canary property back. So let's search a little bit, make sure that we don't have it. We don't. So we're gonna go back to properties and we're gonna do function critic. Let me just critic underscore check the canary public returns bool. We return true by default, and then if counter dot number greater than 118, we will return false, and we break the property in that way. Obviously, this will be a Recon number, which is something we want to introduce via dynamic replacement in the future. But for now, let's just do a quick and dirty setup. Again, we expect the target functions to be change target to engage the proxy, counter set number, and then the property should be broken. So let's see if we achieve it. We can, again, scarily see that this is not being achieved as of now. And so that's where we would have to go and check the coverage. So first of all, at this point, there will be two ways to debug this scenario, but I'm just going to show you the naive way of opening Medusa and checking the coverage report. So let's do that. Coverage report, blah, blah, blah. Target function dispatch.sol. So we can see that it's being called, but that doesn't mean anything because we have to go to our proxy, which is here, and we can see that it's called, but now we have to go to the counter.sol contract, and we have to see what happened to it. So we can see that this was actually successful. So this may actually be the case that well, let's see if this is being called. It is. So this may be the case that in adding this extra layer, we are actually making Medusa lose a little bit of its coverage guided aspect, and so this may actually be the downside of what we did. I am tempted to just run Echidna to actually see if Echidna doesn't get fooled by the additional complexity, because I would expect, unless I missed something, because maybe this Medusa file is actually wrong. So no, yeah, this is actually a good mistake to make. Property testing means that you're testing for the return value of your tests, and so this is called critic. But in the Medusa.json that we shipped in the original Create Chimera app, we used invariant underscore. And so this is why the property is not being tested as a property. And so first of all, I'm just going to change the name, and perhaps it was just a fluke due to that. And so this is why the config file on these tools is so important, is because you can actually spend a day thinking that you made a mistake, whether in truth it was just the settings. There you go, it was just the settings. And so the only difference is that we would expect the actor switching to be engaged, And that's exactly what, like Medusa, like clockwork, literally gives us the minimal POC of changing the target to somebody that can call and then setting the number to a number that breaks the property. And so the discussion here is whether you think that having an explicit switching, which means that you no longer rely on message.sender, so it's easier to debug between Foundry and Medusa, so that's a plus. But the explicit switching is making it a bit easier to understand what's going on. And so I lean towards the idea that this is better for everybody because we are not writing in low-level code. And so if we want to have a try-catch, we can always go back to the try-catch. But if we don't want to, we don't have to. And I feel like it's a lot more inviting as a starter. But I'm really curious to hear your thoughts on this. Do you feel like, even though I struggled, do you feel like this is better? Or do you feel like it would actually be better to have or actually you're indifferent to this? What do you guys think? What was your preference? Proxy may be easier, fair. Proxy may be easier, although eventually we will always automate the entirety of this. So potentially this will be a lot simpler in the future for both. So proxy may be easier, target dispatcher seems cleaner for bigger projects. So I guess I think what we can conclude from this discussion is that they're kind of very similar. And so if you are going to well, let's think about the mistakes that you can have though. Let's think about the mistakes that come from this versus that. So this is obvious. And so the only problem is if this is unset. So the way you will test this is you will just do a t-false counter increment. And so if this is unset, this is never called. And so that's how you will test it. Whereas if you are setting up the actor proxy and you're debugging it, then a t-false would always pass, because what you will want is to check for success. But as you know, success is true when calling a non-existent contract. And so you would actually have to do an xt code size check. And so the downside of the low-level code is that you now are stuck with the low-level debugging and the low-level aspects of the code, which tends to have more gotchas. So that said, the gotcha of the high-level code will be that if you write something like this, which unfortunately I've seen this done, by the way. So if you write something like this and then 1 + 1, or maybe you do type uint 256.max plus 1, the try catch will not catch this revert. And so if you find yourself in this scenario, you will still get a revert, and so you will get a false positive anyway. And so I think both have gotchas. The low-level setup is a bit more better understood, but my opinion is that if we want people to be onboarded into invariant testing, they need to have the easiest, simplest to understand code base. And so I'm thinking that if there was some sort of a pre-processor where you press a button and it automatically generates the dispatcher for you, then I think that the dispatcher would always be the winning option. The issue today is that we don't have a preprocessor, and so we basically can't create this extra contract for you. We would have to add it in Recon. And so it does create some overhead no matter what. And so my advice for you guys is to try both options and see if there is a way for us to generate this fully automatically. Because if that's the case, we could somehow have you pass the target function. You will send us the target function on Recon, you will paste it, and then we will generate you the target function dispatcher for you automatically, so it auto compiles and you can go and use this higher level abstraction. And so the big question left is, how do we make it easy for you to have that abstraction? Because if we can achieve it, then you're gonna definitely have an easier time integrating multi-actor in a way that makes sense. Because as we showed, if you didn't need the multi-actor, then Medusa in a shrinking procedure would actually get rid of it. And so having that multi-actor as a separate step would potentially help you identify sequences that actually require more than one address, instead of sequences that have more than one address simply due to randomness. So my invitation is for you guys to try it out and let me know what you think. I'm going to eventually post the code as we streamline it, and then you can expect that over time that's gonna also become part of the original or I guess of the Recon builder. While I think for the short term we're gonna aim for simpler pieces of code, such as having automatic false assertions, as well as automatic try-catch generation, so that you can have a little better coverage initially to help you write your own invariant tests. That said, unfortunately we had shitty connection this week. Hopefully you can check the recording, and then stay tuned for the next couple of weeks, because we're gonna have a couple of banger episodes. I'm not gonna say anything, but next week I'm gonna praise one of the most hated projects, and then the week after we're gonna do a banger episode from Berlin, so it's gonna be epic. That said, if you have any question, let me know. Otherwise, thank you for attending and have an amazing weekend.